At the distant edge of our solar system, where the planets shrink to faint points of light and the sun itself appears as just another star, a rare visitor has arrived. Born around an alien star and traveling at thousands of kilometers per second, this interstellar object enters our cosmic neighborhood, carrying with it the secrets of another world. More than just a passing body, it is a messenger across the galactic void, a fragment of the wider universe delivered to us from beyond the stars. In the last decade, astronomers have witnessed something unprecedented: the arrival of interstellar objects, cosmic travelers that originated far beyond our solar system. Their sudden appearances have electrified the scientific community and captured the imagination of planet Earth. Each one carries with it the secrets of its home system, the potential to answer age-old questions, and perhaps to ask new ones we haven't even considered. The story began in 2017 at the Pan-STARRS Observatory in Hawaii, when astronomers detected a faint, fast-moving point of light. That object would become known as Oumuamua, the first interstellar object ever observed passing through our solar system. Its strange, cigar-like shape and peculiar trajectory challenged our understanding of what such visitors should look like. Some, like Harvard's Professor Abraham Loeb, even speculated about artificial origins, proposing that Oumuamua's odd acceleration might be the result of solar radiation pressure acting on a thin, possibly manufactured surface. Just 2 years later, the saga continued with the discovery of 2I Borisov, a true interstellar comet, its tail blazing as it swept past the sun. And now, in the summer of 2025, a third interstellar visitor has been spotted, 3I Atlas. Detected by the Asteroid Terrestrial Impact Last Alert System in Rio Hurtado, Chile, 3I Atlas is streaking through our solar system on a trajectory that brings it tantalizingly close to the giant planet Jupiter. The arrival of 3I Atlas has led to a flurry of scientific excitement and speculation. Each of these interstellar objects offers a rare window into the processes that shape planetary systems far beyond our own. Could their composition reveal the fingerprints of exotic chemistry? Might their structure hint at the way worlds form and evolve around other stars? And in the most extraordinary scenario, could these objects be more than just lumps of rock and ice? Could they be the relics or even the artifacts of alien technology? The sheer challenge of intercepting one of these cosmic interlopers is immense. Unlike comets and asteroids that orbit our sun, interstellar objects move on hyperbolic paths, flying through the solar system at breakneck speeds and unpredictable angles. By the time we spot them, they are already racing toward the outer darkness, giving us only a fleeting chance to study them up close. Scientists have proposed ambitious missions to chase down these objects. Concepts like Project Lyra envision using light sails and powerful lasers to accelerate spacecraft to incredible speeds, allowing them to catch up with a fast-departing ISO, or interstellar object. The Interstellar Object Explorer and the European Space Agency's Comet Interceptor are designed to wait patiently at strategic points in space, ready to spring into action when a new visitor is detected. But with 3I Atlas, something remarkable has happened. A new analysis led by Professor Loeb and collaborators Adam Hibbard and Adam Crowell suggests that humanity may already have a spacecraft in the perfect position to intercept this interstellar traveler. That spacecraft is NASA's Juno probe, currently orbiting Jupiter and carrying a sophisticated suite of scientific instruments. The proposal is as audacious as it is elegant. By executing a carefully timed maneuver, an engine burn to change its velocity, followed by a gravitational slingshot around Jupiter, Juno could be redirected onto a path that intercepts 3I Atlas as it sweeps past the gas giant in March 2026. This maneuver, known as a Jupiter-Oberth maneuver, leverages Jupiter's immense gravity to maximize the probe's speed and efficiency, catapulting Juno into interplanetary space on a collision course with the interstellar comet. This opportunity is exceedingly rare. Most interstellar objects slip through the solar system without coming anywhere near a planet, let alone one with an active spacecraft in orbit, and launching a new probe from Earth to intercept 3I Atlas is simply not feasible. The warning time is too short, and the object is moving too fast. But the serendipity of 3I Atlas's trajectory, passing close to both Mars and Jupiter, means that for once we might actually catch up. The team's calculations, using sophisticated software packages and orbital mechanics tools, show that by applying a change in velocity of just 2.675 kilometers per second at precisely the right moment, Juno could break free from its current orbit and meet 3I Atlas head-on. The probe's array of instruments, its near-infrared spectrometer, magnetometer, microwave radiometer, gravity science instrument, energetic particle detector, radio and plasma wave sensor, ultraviolet spectrograph, and visible light camera would be able to collect unprecedented data as the two objects converge in the darkness of deep space. Why does this matter? Interstellar objects are time capsules from other star systems. Most of what we know about the universe beyond our solar system comes from telescopes, tiny points of light, spectra, and indirect measurements. But a close encounter with 3I Atlas would be something different. This would be the first time a spacecraft launched from Earth could directly examine matter forged around another sun, in another place and time. It's a scientific opportunity that, until recently, belonged more to science fiction than to reality. And as Professor Loeb and his collaborators point out, the story gets even stranger. The origins of 3I Atlas, its size, brightness, and highly unusual trajectory have raised questions about the possibility of artificiality. While recent Hubble Space Telescope data suggest the nucleus is smaller than first thought, measuring less than 2.8 kilometers in radius, the true nature of these objects remains shrouded in mystery. Could 3I Atlas be a derelict probe, a relic of alien engineering, or simply a product of the chaotic forces that shape planetary systems? Regardless of what we find, the stakes are enormous. By seizing this rare chance, scientists hope to unlock new secrets about planetary formation, the chemical diversity of the galaxy, and perhaps even the prevalence of life, or intelligence, beyond Earth. The countdown to a possible encounter is on, and the eyes of the world are once again drawn upward, to the dark and wondrous frontier of interstellar space. The opportunity to intercept an interstellar object like 3I Atlas is nothing short of extraordinary. In the vast emptiness between the stars, these cosmic visitors are rare, so rare in fact that only 3 have ever been detected passing through our solar system. Each one is a message in a bottle from another world, and now, for the first time, we may have the means to reach out and grasp that message directly. The key to this unprecedented encounter lies with NASA's Juno spacecraft. Since 2016, Juno has been orbiting Jupiter, peering through the planet's dense clouds, mapping its magnetic field, and unlocking secrets of the solar system's largest world. But now, thanks to a cosmic alignment and some ingenious orbital mechanics, Juno could be repurposed for a new mission, intercepting 3I Atlas as it sweeps past Jupiter in March 2026. This maneuver is possible due to a remarkable coincidence. As 3I Atlas makes its closest approach to Jupiter, Juno will be in a favorable position to alter its trajectory, using what's called a Jupiter-Oberth maneuver. Named after the pioneering rocketeer Hermann Oberth, this maneuver takes advantage of Jupiter's massive gravity well. By firing Juno's thrusters at just the right moment near the planet, the probe can gain a slingshot boost in velocity, bending its path to align with that of the interstellar comet. Calculating this trajectory is far from simple. The team, led by Professor Avi Loeb, Adam Hibbard, and Adam Crowell, harnessed advanced software tools to solve the intricate three-body problem: how to synchronize the orbits of Juno, Jupiter, and 3I Atlas to enable a close intercept with minimal fuel. Hibbard's Optimum Interplanetary Trajectory software, developed initially for Project Lyra, and custom C language programs utilizing NASA's NEF-SPICE toolkit allowed the researchers to model the orbital dynamics with extraordinary precision. The result? A planned sequence of velocity changes, referred to as delta V, executed in September 2025. Just days before Juno's originally scheduled descent into Jupiter's atmosphere, these carefully timed burns would send the spacecraft on an intercept trajectory, targeting a rendezvous with 3I Atlas at the very edge of Jupiter's realm. If successful, Juno will become humanity's first spacecraft to fly past an interstellar visitor and study it up close. The probe's array of scientific instruments, designed to study a giant planet, will be turned toward the alien intruder. Its near-infrared spectrometer can analyze the composition of 3I Atlas's ices and dust, searching for telltale chemical signatures that hint at its origins. The magnetometer and plasma wave sensors will probe the interaction between the comet and the solar wind, while the energetic particle detector could reveal high-energy interactions as volatile compounds sublime in the warmth of the sun. Juno's visible light camera, along with its ultraviolet spectrograph, will image the nucleus and the expanding coma, capturing details as 3I at Atlas transforms under solar heating. Gravity science experiments may even yield clues about its mass and internal structure, data never before obtained for an object from beyond our solar system. The implications of these measurements are profound. By comparing the physical and chemical properties of 3I Atlas with those of comets and asteroids native to our own solar system, scientists can begin to unravel the story of planetary formation on a galactic scale. Are the ingredients of life common? Do other star systems spawn icy wanderers like those that seeded early Earth? Each spectrum, each image, each data point returned by Juno will help answer these questions. Of course, some hypotheses are more speculative than others. Professor Loeb, known for his provocative suggestion that Oumuamua may have been an artificial object, has not shied away from considering the technological possibility with 3I Atlas. While recent Hubble Space Telescope observations suggest the nucleus is smaller than initial estimates, less than 2.8 kilometers across, the debate about its nature will only be settled with direct exploration. Whether 3I Atlas is an ordinary comet, a fragment of some ancient planetary collision, or even something more exotic, the science will be transformative. As it approaches the Sun, astronomers will observe it with ground-based telescopes and space observatories, watching for changes in brightness, structure, and composition. If Juno can intercept it, the probe's instruments will provide a close-up view that could redefine our understanding of interstellar wanderers. What makes this opportunity so unique is its sheer serendipity. Most interstellar objects pass through the solar system at immense speeds and on unpredictable trajectories. By the time they are discovered, it is usually far too late to mount a dedicated mission from Earth. The proposal to use an existing spacecraft, already in deep space and equipped with a robust suite of instruments, sidesteps the lengthy timelines and logistical challenges of launching a new probe. This level of rapid scientific response is unprecedented in planetary science. It showcases the flexibility and ingenuity of mission planners, as well as the immense potential of creative thinking in space exploration. The data returned from such a flyby would be a treasure trove, not just for planetary scientists, but for anyone curious about the diversity of worlds beyond our sun. As we await the outcome, anticipation builds across the astronomical community. Will Juno's mission be extended and redirected to chase down this cosmic visitor? Can its aging systems endure the rigors of a new flight path, the deep cold, and the radiation of interplanetary space? If all goes according to plan, the next chapter in humanity's exploration of the cosmos may be written not by a brand new spacecraft, but by a veteran probe, repurposed at the edge of the unknown. In the coming months, as 3I Atlas draws nearer and preparations continue, telescopes around the world will focus their gaze on this interstellar wanderer. The world watches and waits as we prepare to meet, for the first time, a true interstellar traveler in the flesh, a piece of another solar system here on a fleeting visit, ready to reveal its secrets to the instruments of Earth and the ingenuity of humankind. As 3I Atlas sweeps through our solar system, the scientific world stands on the threshold of a new era in interstellar exploration. The possibility that NASA's Juno spacecraft, a veteran observer of Jupiter's majestic storms and magnetic mysteries, could be retasked to intercept this cosmic wanderer represents a remarkable convergence of timing, technology, and celestial mechanics.